How's everybody doing today? I'm still getting my life together. So far it looks good. Everything seems to be in place. I will give you guys a hot second to pop into the live before we get started. As you get here, if you have a question, go ahead and drop that right in that comment box. When we get about 30 people in, hopefully we'll get that many today, I will give you guys some updates, try to answer some questions about Alex that you guys have been having. Some of you may be having, maybe not all of you. Sorry, I'm a little late today. We're having some slight technical difficulties in this space. So Elizabeth says it's a little frozen. My guess is that you can, in your, you can change the display rate. It's not the right words. So it's frozen and basically make it at a lower resolution, if that makes sense. Otherwise, it's going to take us a hot minute to get together. So my suggestion would be to actually leave the live. If that doesn't fix it, if going at a lower resolution won't fix it, go ahead and pop out and then just come right back. You might have to quit your browser. Sorry, I know. It's just a hard thing. When it glitches, it's likely on your end. That doesn't sound helpful. Yeah, I teach another class right before this, and it's on the other side of campus, and so I had to run back and forth. So good question. So Jenna G asks, when you finish the Alex module, does it automatically go to Canvas? Short answer, no. So I go in and update those, and so I haven't gotten there yet. That's right. I will likely wait and do it next week when you guys get 2 of them, just because it's a little bit easier on my end. So that's going to happen. But let's talk about Alex. So a number of you have probably taken your first knowledge check. And now maybe parts of your pie are not the same as they were last week. So your grade is composed of 2 parts. 1, doing it every week. If you do all of the objectives every week, or whatever you get done, you get that percentage of the score. So if you do 8 out of 10, you get 8 points out of 10. The first couple of weeks have more objectives. They will decrease in the number as we go forward. You'll still have about 10. So the next thing is, turning them in on time. So you turn them in on time. Then you can go back and do the knowledge check. So the knowledge check asks, did you actually learn anything? So after the knowledge check, it may be could you review these? So the reviewing of those things may be as simple as you need to answer a few more questions, or it can be that you have to do the whole, get 3 right in a row. Sometimes you only need 2, sometimes you need 3. They will be the objectives that maybe you had a hard time with before. It's asking you to actually look and learn. So the ones that it takes away, you need to get back by the end of the semester. The pie score, I'm going to do that during the final exam. So you have from now until April to not to figure that out, but to get it to 100%. I do think I'm going to try to update that score so that you guys can mentally prepare yourself, but Canvas might have a little meltdown about the math, and so I'm not quite sure how to do that just yet. So Christopher asked, can you review topics? You certainly can. When you sign into Alex, there's a way to do this, and it's super easy. I think it's on the right side, can go from learn to review. I might try to make another video where we can walk through Alex together. I posted one on Friday of all the cool things that are in our Canvas site, so you can find the worksheets, where the syllabus is, and everything else. So Paula says it doesn't let you go back. So it's locked on the learn screen. If you go to the review screen, it unlocks anything you've already learned. I know it's kind of complicated. Also, you should be able to go back anytime you finish early. So if you finished this week's assignments today, then that would be the next piece. So Sergey asks, how do knowledge check works and how do I grade that? So a couple of you have asked, there aren't any due dates on a knowledge check. So a knowledge check is like that thing you did at the beginning where it says, what have you learned? It will ask you about stuff that's coming in the semester, so you can always test out on those kind of things. The ALEKS questions will basically, I've seen all of the different questions about the mini exams. We will get there. You guys can just hold on to those. I've seen most of those. We'll talk about that in a minute. So the knowledge check basically asks, what have you learned? So there's no due dates, but it will make you do it before the next. So you should have one this week. You need to plan for that. It should take about 45 minutes before you can get into this week's objectives. So if you've already done it, great. You may have seen some of your pieces move around. It's not a big deal. But if you look in your grade book, it should tell you if you had 100% on whatever date or something else. Elizabeth asks, how long do you have? As long as it takes. ALEKS won't let you move on before that. But the knowledge checks don't have a date. So you just need to take it in order to get into the next ones. So, and they are not part of your grade. So I feel like I thought that at y'all, but I didn't say that. The knowledge checks are not part of your grade. So it's basically, you had one this week, and you'll have one right before the exam. The idea is to find out, like, oh, I don't know this thing. And so then you can study it before the exam. Okay, let's see if there's any other questions. If I've missed your ALEKS only question, you can go ahead and rewrite that in the chat. But let's talk about the mini exam. So the mini exam will be on Canvas on Monday. On Friday, you want to make sure that you look at the announcements. Elizabeth said this week's objectives are due February 1st. They should be due whatever next Monday is. So you do have objectives due on Monday, the same day the quiz is. There'll be Chapter 3, Part 1 due this week, Chapter 3, Part 2 the following week. But I don't have a copy of the syllabus, so I'll double check on that. But I'm pretty sure they're all correct in ALEKS. The mini exam. It will be on Canvas. A new module will open on the modules page. It will open on Monday, roughly around, it'll open a little bit before 4:30. You're gonna have 22 minutes. Like all of the exams, it will be open notes. It is not open Google, okay? You have to show your work. Well, how's that gonna work? So what you're gonna do is you're gonna take it. There will be some number of questions. I don't know how many because I don't have that. So you will take the mini exam. You're gonna answer those questions. You can use your notes. You can use the textbook. You can use my YouTube videos. You will not have enough time to go looking for information. If there are 3 questions, well, there will be more than that. For every one of those that requires work, you should show that. You are going to, using Cam Scanner or another program, create a PDF. You should practice doing this. A single PDF, not 7 different PDFs. It'll probably take you more than 1 page. You'll take pictures, upload them. It has to be a PDF. It will be locked to not take pictures. So you will upload your work. Canvas is going to get the first crack at grading. Canvas is not the smartest computer, and that's okay. I will go back and regrade both your work and what's on Canvas. You can earn additional points If you've made a sig fig mistake, maybe you'll get 8 out of 10 instead of 0 out of 10. You have to show work. If you don't show work and it's wrong, you can't get any partial credit. So you're gonna have to upload your work. That will be part of your grade. No work, no opportunity for partial credit. So you'll upload those things. You have to upload the work within 15 minutes of the exam, or of the mini exam. This will be true for all of our graded material. It will be on Canvas. And so this mini exam will cover everything through today. So next week there's new material. The mini exam will not cover 3.5 and 3.6, I think are the videos. Basically, if you use a balanced equation to like calculate something, it's not going to cover that. But it will cover everything through these videos. Sterling asked, you have 22 minutes? You have 22 minutes unless you have an accommodation letter, in which case you will get whatever that provides for you. Okay. So Christopher asks, do we upload our work during the exam? It'll be after. So you have 22 minutes to finish the mini exam. Then you have to upload your work within 15 minutes. It has to be uploaded through Canvas, otherwise it's really hard for me to grade. One document. I will open a practice upload this weekend. I'll attach that so you can basically upload a picture, upload 2 sheets of paper so that you know how it will work, okay? So that will be there. It can be after as long as it's within 15. So Elizabeth asked how long? 22 minutes. So it's 50 points, 22 minutes. It's roughly 25% of how long you get in the exam. The number one thing that students say is they didn't have enough time to finish. That means that you need to be prepared. You're going to want to review. You're going to want to make a study guide. You will need a periodic table. Make sure you have that. Hope asks, is there a special module grade to be able to send in the PDF work, or is it part of the mini exam? That's a great question. So the module will actually have 2 parts, one for the quiz and a separate upload assignment, so that you're not trying to upload during the 22 minutes. You should take the 22 minutes, or as long as it takes, within 22, answer all the questions, finish everything. When that 22 minutes ends, it will either submit it for you or you will hit submit. Then you should take pictures of your work and upload them after. It should, if I get Canvas right, be basically like hit submit and the new module should open. You'll find it on the Canvas page. It will open a little bit before 4:30. You have to have taken it between 4:30 and 5. So where do we start it? And then the exam, do we choose? So Elizabeth asks, when do we start? You need to start between 4:30 and 4:45. You have 22 minutes once you do that. At 5:30 on Zoom in my office hours, I will rework all of the problems from the mini exam. So if you were like, oh my gosh, I didn't finish, come, I'll show you how to do it. If you would like to pseudo check your work, you can do that. Paula asked, do you print it out? No, so you should work it on like either white paper and just say like, number 1. Oh, you got that. That's right, Sterling. I don't know yet. I have a half sheet of torn paper with some ideas. Last semester, my big exams had 20 to 30 questions, so somewhere between 5 to 8. Kind of depends on how they break out. But it's about 50 points. You should think through the fact that this is roughly a quarter of what the exam will be like. So if you cannot finish the mini exam in 22 minutes, you're going to have to figure that out. Elizabeth, I did not say no more than 3. It will definitely be more than 3. There will be lots of them. Sergey, this one is not on Honor Lock. There's a limit. Oh, Possum King, and someone else asked 3.5. Yes, I do mean chapter 3, part 5. Sorry, I see your questions and I think answers at you, but I forget that you can't read my mind. So sorry about that. All right, any other questions? I like this question and answer period. I'm not seeing any other just yet, so you guys can go ahead, as always, drop them in the chat box while we move along. I am going to go ahead and start on the questions. So these are going to work, I think, roughly in order of the material out of the textbook or out of the videos. Don't forget, there are other videos where if you're like, where did she get that information? You can find some of that info in the other videos, which do not have this going on. It's more like a slide that I write all over. So you can find the information there. So Christopher asks, is there a way for us to get an idea of what questions that might show up? You can use the worksheets that you can find. You can use the live sessions as a good example. Otherwise, there isn't anything beyond all of that material. Or you guys can go to SI. So in SI, you guys will probably, maybe there's a mini exam. And so any of that information. All right, let's start with number 1. So in this case, number 1 asks for 3 different balance these equations. So I'm going to go ahead and start with part A, and we'll go from there. Do the worksheets help you study? These, it might be of interest to you, but there are no multiple choice in my course. I hate multiple choice. Oh, y'all, there's a mock mini exam tomorrow in SI. I gotta stop reading the chat so that I can focus. The worksheets will help you study. They're problems that I wrote. They're just more examples. The types of questions that you'll get, what might be something like this: balance this equation, show your work. What are the coefficients? There's lots of different ways we can ask that. Sergey, you can always send me an email, unless you're asking for my email address, in which case that's not very helpful. But you can find my email, and I will add Mahi's to the homepage in our course, so we can do that later. Okay. Number A, for number 1. So we have the following question. It asks for the combustion of propane, C3H8. So we know that it's C3H8. A combustion reaction has known parts. It's O2, and it turns out, at least for the purposes of Gen Chem 1, a combustion reaction is really simple. And y'all can't see that at all. So let me find a different marker, because I think that's the bigger problem. There we go. So combustion reactions. We have a flammable component plus oxygen gives us H2O plus CO2. And so in this case, we need to balance those. We are looking for the big numbers in front. Hey, Matt, you have asked a couple of times of what chapters are on the mini exam. So a little bit earlier, we talked about that. It's everything through today, chapter 1, chapter 2, and the first parts of chapter 3. So in this case, we have this. So in a combustion reaction, which y'all can't see, hold up. This, like, I don't know what's happening, but you can't see anything. But we're just going to have to roll with it. That's not going to help. So, how do we balance this? We need to know what we have. So we're going to write our components, C, H, and O, on both the left and the right side. It's important to make sure that these are lined up with one another. If they're not lined up, then you can't balance them. Because you're going to look all the way across and be like, oh, I see that. So on the left side, we have 3 carbons, 8 hydrogens, 2 oxygens. On the right side, 2 hydrogens, 3 oxygens, 2 plus 1, and 1 carbon. One of the questions students always want to ask is, well, how do I know where to start? It's a great question. In terms of balance an equation, anywhere. So my suggestion is to pick any one of these to balance first. The trick is just one at a time. So I'm going to start by balancing this side because there are more carbons and more hydrogens. So I'm going to try to balance the hydrogens. I'm going to put a 4 here. When I do that, that gives me 8 hydrogens, and it's going to give us 4 oxygens. So, but the carbon dioxide can't be just left alone because that's not going to cut it. So what we're going to do is we're going to add a 3 here. So that gives us a 3. Now we need to figure out how many oxygens there are. Plus 6, that gives us 10. So our carbons are balanced, our hydrogens are balanced, the oxygens aren't. But it turns out because there are no oxygens present in propane, we can actually just add a 5 here, so that will give us 10. So then we can rewrite our fully balanced equation of C3H8 plus 5O2 gives you 4H2O plus 3CO2. If I had provided you the states, you would have to have that information. But in this case, it didn't ask for it. Now we know that oxygen is a gas, the production of water and CO2 are both gases as well, so you could add those in if you want. If the states are there, you're going to have to add them. If the states are not there, you don't need to add them. So it looks like, is there a list of compounds you're going to have to know for the exam? That is covered in the videos. So in chapter 2, I believe it does tell you you need to know some of the alkanes and alcohols. That list is provided in there. You can, if you are like refusing to watch the videos, which is a bad idea, you could, in fact, just look at the slides. It's also annotated in the chapter 2 slides. Otherwise, you can use the naming skills that we talked about last week to name them. So Hope asks, order doesn't matter. Can I have H? Oh, good, Hope. I was like, it doesn't matter. So Hope's question is, can we swap the order of these? You can do, I don't want to say anything you like, but you can move them around anyway. So let's look at B. I'm going to move this up so that you guys can actually see it. So we have FeOH3 plus H2SO4 goes to Fe2SO4 plus H2O. Now, this one is way more intimidating than part A, right? We got a lot of components. There's things everywhere. What do we do now? So it turns out that by and large, for not equations like this, because this is different, but a lot of times they just break up into 1 or 2 parts. We don't really see equations in Gen Chem 1 where they break up into like 4 and 5 parts. So as we start to think about this, we can use that to our advantage. So if we have FeOH3, I'm going to leave the states out now, but I will add them back in later, plus H2SO4 gives us Fe2SO4, 3 plus H2O. So today, in chapter 3, you are not going to be provided just the left side of the equation and asked to come up with the right. Right now, we're looking at equations where you have all the parts. So I'll say that again. Not now, but in chapter 4, I will teach you how to look at this and predict the products. But right now, we're just asking you to balance equations where all the info is there for you. So this looks intimidating, but all of these can be broken down into an anion component and a cation component. And so we can balance them in that way. So we're going to have Fe and OH, protons, and SO4. Now, this proton here comes from the H2SO4. This is what's called an acid, and so the acid basically, these two come off. We'll talk more about that in chapter 4. But for now, we just need to know that it happens. So we also have the same components over here. So we're going to count them up. We have 1 iron, 3 hydroxide, 2 protons, 1 sulfate. 2 irons, 3 sulfates, 2 protons, and 1 OH. The H2O decomposes into an H plus an OH. Now, this is a little weird and a little complicated. You don't want to start trying to split it out and count oxygens and hydrogens. Here's why. Because the oxygens in this sulfate make the summing of all of the oxygens really complicated. So if you can leave something grouped together, it's going to make it easier in the long term. So now we've got to figure out how do we write, what do we do now? So we're going to start by balancing the iron. But in this case, we're going to balance on the left side first. So we're going to add a 2 here. And when we do that, now we have 2 irons. And we have 6 hydroxides. So we're going to have to come back to the other side, but that's not bad. Protons, hey, those are the same. But the sulfates, we have 3 on this side and 1 on this side. So we're going to add a 3 here. So now we have 3 plus 6. So we're unbalanced again. This is also should be a 1. So in this case, we're going to add a 6 here, which will give us a 6 and a 6, and now we're completely balanced. So we can rewrite our equation, this time including our states, 2FeOH3 solid plus 3H2SO4 aqueous, goes to Fe2SO4 3 aqueous plus 6H2O liquid. So we can balance our equations by making it easier by just separating them into anions and cations, and then they separate in this way. Now, if you stick around in chemistry and take organic or something with a little bit more complications, this trick might not always work. But in Gen Chem 1, it's almost always going to work. So, Jenna asks, is it okay if you break something up differently? You can. I am teaching you what I consider the easiest way to balance an equation. You may not agree, and I'm not offended. So if you have a different way to do this, where you separate into the elements, that is totally fine. I find that way to take a little bit longer and a little bit more complicated. So I think Hope and Jenna are asking the same question. You totally can. It will get much more complicated. What is say on the left? Is this what you're asking about? So Christopher asks, what does it say on the left? It's basically a rewriting of this, but including the states that came out of the problem. If that's not what you're asking, go ahead and drop it in the chat. And I will move this up so we can look at our third one. So when we look at this is this, but I added the states. So there, it's just the information at the top. No, you're fine. So, okay, let's think about what do we do next? So Haynes is asking about, I don't understand separating it. So water, in this case, comes from a single H plus and an OH. You can separate these differently than I did. When you do that, it makes it more complicated. So you could have set it up differently, but if you make the OH and the AH, it matches the anions and cations that you see on the left side. If you break water up differently, this method is not going to work because of the sulfate ions, which also have oxygen in them. You can definitely do it a different way. This is just the way that I think is the easiest. If you guys have questions, I encourage you to stop by SI this week. I know you guys are going to balance equations there. I have a whole video on different ways to balance them. You can also, I have office hours this week. I sat in my Zoom room alone. If you pop in and I don't let you in, that means I'm in a meeting with another student, so you can just hang out in the waiting room. And so you can do that. But let's look at part C. In part C, we have the following equation. Aluminum nitrate plus sodium sulfide gives us aluminum sulfide plus sodium nitrate. Now, you'll notice that I am trying to say these out loud. You should practice naming. Every compound you see, say like, ooh, what is that? So here we're going to have the aluminum, the nitrate, the sodium, and the sulfur. 1 aluminum, 3 nitrates, 2 sodium, 1 sulfur. On the product side, 2 aluminums, 1 nitrate, 1 sodium, 3 sulfur. So now we need to balance this. We could start by balancing the sodium and the nitrate. My suggestion would be to balance the aluminum or the sulfur first. Or in this case, we're going to do both. So we're going to balance the aluminum by adding a 2 here. We have a 2 plus a 6. Now we're going to do the sulfur. We're going to add a 3 here. We're going to get a 6 and a 3. So now the aluminum and the sulfur are balanced, but the sodium and the nitrate are not. But luckily, these are in a 1-to-1. So we can add a 6 here, which gives us this. So we can rewrite that, which I'm not going to do for time, but you should if it asks. So this one, a little bit easier, a little bit less parts. When we balance equations, if you have to go back and forth more than twice, so sometimes what you'll do is you'll balance this side and then realize that these are still off by maybe a factor of 2 or 3. So then you'll rebalance the other side. If you're going back and forth like a teeter-totter or a seesaw, double check that your equation is right. It should only take tops 3 rounds, at least in this course. In other courses, it might take longer. But in this case, if you balanced the sodium and the nitrate first, which a 2 and a 3, that was never going to work Because if you added a 2 here or a 3, it wasn't going to give you the right information. You would have to do more in order to do that. What questions do you guys have about balancing equations? And if you don't have any questions, you can go ahead and write none in the chat, and we will, actually, we're going to move to number 2. If you have questions, drop them in the chat, and I'll get back to those. So the next thing we're going to do is start to calculate the atomic weight. Atomic weight is pretty simple. So the atomic weight, we're just going to add up all of our components from the periodic table. I have a copy of mine. Hopefully you do too. So we're going to go ahead and look at those. I will come back. If you guys drop questions, I will answer those in a minute. So for strontium carbonate, the atomic weight is composed of strontium, carbon, and oxygen. So strontium, carbon, oxygen. So there are 3 of these times the weight from the periodic table, rounded to 2 decimal points. And then you can add these up, and I get 147.68 grams per mole. So that would be A. For B, I'm getting, so for silicon titanium dioxide, there is 1 silicon, 1 titanium, and 2 oxygens. So if you look at the periodic table, it reads 15.99, 15.999, something like that. In this class, we're going to round to 2 decimal places. I will always round to 2 decimal places. You don't necessarily have to, but we're going to. 2 times 16. For titanium, the weight is 47.87 and 28.09. When you plug these into your calculator, you should get 107.93 grams per mole. While you guys work on C, I'm going to check the chat. So Nicholas, and I think someone else, or Nicholas, do you need to know the states? If I give them to you, please use them. If I don't, you don't need that information. Robbie asks, do you need to show the work? You need something. I show you probably more detailed work than most of you would use. But if it asks you to do that, it will also tell you to rewrite the equation, so your work could be in there. Zach asks, for future reference, when predicting products from given reactants, do the reactants just swap? Most of the time. I like to call it a little chemical do-si-do, but that's because I'm from Texas and I like a good square dance. You are off by 100. Mine feels like y'all should be off by a few more than 100s. Because I can tell, like just doing some mental math, 2 plus 1, that should be 3. And this should be 6. If I make those changes, is that what you get, Jenna and Anasha? If it's not, let me know. But I'm pretty sure, I think that's what happens. Okay. I don't know what happened, but I think that's it. Okay, good. So part C, we have calcium phosphate. So there are 3 calciums, there are 2 phosphates, and there are 8 oxygens. So we have 3 times 40.08, 2 times 30.97, and 8 times 16.00. And because I have apparently done none of the other math, I'm going to check this just in case before I write up the answer. I get 310.18 grams per mole. After you multiply by. Okay, y'all are answering each other's questions. Matthew, you, as it's open notes, you can use almost any periodic table you like. You do need to have a periodic table. I will put one in the quiz in case you like totally forget and don't have one. It'll be in there at the beginning, but that's what you got. All right. So this is how you calculate the atomic weight. Again, in my class, it is my expectation that you round to 2 decimal points. More than likely, the atomic weights are never going to control your significant figures. Multiply by 3. I think y'all are having a conversation that I don't need to be a part of. Okay. If you have questions, go ahead and drop it in the chat. We are not going to do all 4 of these because we are going to run out of time. But we will do 2, and then we will come back and do 2 more at the end. Or you can send me your work, or I will post the answers to these. But I do want to make sure that we make it to the stuff at the end today to give ourselves a little bit of variety. So I'm going to choose to do A and B. We will either come back to C and D, or I will post the answers, or you can send me an email. In A, it says, how many moles are in 15.35 grams of nitric oxide? So we're going to convert from grams to moles. So this all lumps under the Avogadro's number in different ways that it works. So we're going to take our 15.35 grams of nitric oxide, and now we're going to start to set up dimensional analysis. There are many different ways that you can set up a dimensional analysis problem. I'm going to show you the way that I do. You may like a different way, but the only thing that you have to have is work. A bunch of numbers strung together, it's really great if you get the right answer, but I can't give you partial credit if you don't show enough work. So in this case, we're going to, on the bottom, put the molecular weight, which is 30.01 grams of nitric oxide in 1 mole of nitric oxide. From here, we're going to divide 15 by 30 and get 0.5115 moles of NO. So every time we do a calculation, we want to make sure we're taking into account the number of significant figures. In part A, way up here, there 15.35 has 4 significant figures. No matter how many significant figures were here, it doesn't change. So the number of significant figures comes from the problem. Or I'll ask you a question and then tell you how many sig figs. If perhaps it's something where there aren't sig figs based on like the type of questions. We'll see an example of that later today if we get there. So if you have questions, I know we're starting to move a little fast, but I want to make sure we get through a lot of this today. If you have questions, please drop them in the chat. I will answer them after I solve part B. So in part B, it states, calculate the mass of iron oxide, Fe2O3, that contains 2.095 times 10 to the 9 oxygen atoms. This one came not directly out of your homework system, but real close. So we're going to take our 2.095 times 10 to the 9th oxygen atoms, and now we're going to convert. We need to get to the number of moles. So we need to figure out how many atoms are in 1 mole. So there are 3 oxygen atoms. And 1 Fe2O3 atom. And there are 6.022 times 10 to the 23rd Fe2O3 in 1 mole of Fe2O3. Now we need to convert that into grams. In 1 mole of Fe2O3, there are 159.70 grams. When you plug this into your calculator, there are a bunch of other numbers. None of these control the number of significant figures. The number of significant figures comes only from this element, and there are 4. So our answer should only have 4 as well. So it's 1.852 times 10 to the negative 3rd grams. So what questions do we have about either of these? Anissa asks, you want us to email our work? No, if you do this worksheet and you want me to see if you've done it right, you can email it to me. Otherwise, you do not need to. I'm sorry I was unclear. You don't need to send me your email work at all. But if we don't do this, because we're not going to do C and D, we might come back, but I don't know. So if we come back to those, then I won't post the key. But if you've done them today and you want to know if you got the right answer, you can email me a copy of that. 159.7 is the molecular weight. So that would be of Fe2O3. So do you have any? Okay. So Jenna says she got a little lost. So this is when it's really helpful to have written out lots of work. Because we start with oxygen atoms in a sample, and we want to know how many grams there are. So we have 2.95 times 10 to the 9th oxygen atoms. In every 1 Fe2O3, there are 3 oxygen atoms right here. So 3 oxygen atoms and 1 Fe2O3. You could use molecule or atom or group. And there are 6.022 times 10 to the 23rd Fe2O3 molecules or compounds and 1 mole of Fe2O3. But it asks for grams, so in 1 mole of Fe2O3, there are 159.7 grams. You could have done this calculation in a different order, and you should get to the same answer. What do we cancel out in the equation? All the units. So oxygen atoms, these Fe2O3s, moles of Fe2O3, just leaves you with grams of Fe2O3. Other questions? Glad I can help. We will come back to C and D. I want to make sure we cover the rest. I think we should have time, but here's what I'll do. I will stay and show C and D in this video, even if it's after 5:45. But if So if you have to go, you can just watch the end of this. It's going to be on my YouTube channel. You can find it later. Christopher asks, where did you get 6.022? That's Avogadro's number. So there are 6.022 molecules in a mole. Let's move on to number 4. So numbers 4 through 8 don't have any multiple parts. And so we are going to just do as many of these. We should finish all of these by 5:45, and then I will come back to number 3. I'm not leaving until I answer it for you guys, okay? So now these are a little bit more, not standard, but a little bit more traditional questions. And so number 4 asks, what is the percentage of silver by mass in silver oxide? So it's asking, in 1 mole, what percent of the mass comes from silver oxide? So in order to do this, if we have Ag2O, we need to first determine what the compound weight is. How much does the whole thing weigh? So it would be 2 Ag plus 1 oxygen. So there's 2 silvers at 107.87. 1 times 16.00. So the atomic weight or the molecular weight is 231.74 grams per mole. So it asks for the percent silver by mass. So silver of the total 231.74 is 1. So it's 2 times 107.87 multiplied by 100. Now, this number came from up here. So it's asking what mass of silver is found in 1 mole of the whole product. So from here, you can plug this into your calculator, and we get 93.10%. This is an excellent example where the problem doesn't tell you how many sig figs you need. If this were a mini exam or an exam, it would say, make sure your answer has X number of sig figs. In this case, I just used 2 decimal places, but based on these values, you could have up to 5. So because it doesn't say, you could have up to 5 because it came from here. I used 2 decimal places as opposed to going with 5. So if you have questions about that, or what questions do you have about number 4? We'll leave that up. I will throw up number 5, which is on top of my head. Let me see if I can make that font just a little bit bigger so you guys could see it. Perfect. So I'm going to leave number 4 up. I'm going to just stand right over here under number 5 and work on this. So it's very similar. What is the mass percent of lead in lead-2 nitrate? Now, Hope, yes. You can assume 2 decimal places if it doesn't say. I thought I wrote it in my notes, but I forgot to add it in here. So in this case, the first thing we have to figure out is what is lead-2 nitrate? So this is where the naming that we worked on last week comes to town. So lead-2 nitrate means that the lead, we have Pb2+. We know that the nitrate ion is NO3-, which means that this compound is PbNO3, 2. So from here, it asks us, what is the mass percent of lead? So we need to think about, what is the mass percent of lead? So first we need the atomic weight. So we have lead, nitrogen, and there's 2 of those, times 14.01. The lead molecular weight is 207.20. Nitrogen and oxygen, there are 6 oxygens times 16. When you plug this into your calculator, you should get 331.22 grams in 1 mole. So now it asks, what is the mass percent of lead? Lead percent, so we only have one lead, so it's going to be 207.20 divided by 331.22, multiplied by 100 to get it to a percentage. So we'll get 62.56% lead. And again, this one doesn't say how many sig figs you need. So you can either go from the values here. So when you add these up, you have 5. So 5 divided by 5 is still 5, or 2 decimal places. On a mini exam or an exam, it will tell you how many you need. Just because, or I will, as long as you have 2 decimal places or the number from the problem, you will be marked correct. So what questions do we have about either of these 2 examples in this case? If you have none and you were like, that's so easy, you can write that right in that chat so that I know that you guys are following along and having a good chemistry time, right? Nice, Zach. So I'm going to take away this problem and that problem. Nice, Hope. I'm going to make this a little bit bigger. Sweet. So you guys, well, I didn't get all of it. Nice. So in 6, we're going to do a different type of conversion. So we have a chemist determine that 0.2836 moles of osmium was used in their reaction. What mass of osmium? Now, most of the time, scientists write it down like, I used 5 grams. But sometimes in other types of calculations, we want to think about moles instead. So, you found this notebook, it has this many moles, so how many grams was that? So we want to convert moles to grams. So in this case, we are going to take our 0.2836 moles of osmium. In 1 mole of osmium, there are 190.23 grams of osmium. Whoops. Then we can basically multiply those 2 values together, and we're going to determine that our scientists used 53.95 grams of osmium. So while I erase this other work so that we can do number 7, did you find that question easy? Or if you have a question, go ahead and drop it in the chat. Because if you have a question, someone else probably does too. Nice. I know, this chapter is full of easy things and really complicated things. It's always great for me to hear that you guys are like, oh, that's so easy. So, y'all are just making my Wednesday. So number 7, also in the tiniest font known to man. These are probably, so Christopher asks, where did the 190 come from? This is the atomic weight. Good questions, guys. I'm glad you had them. The 190 is the mass of osmium from your periodic table, which you can find right here in element 76. In that one, it doesn't tell you that OS is osmium. If I pick like a really weird element and I'm asking you to do stuff, a lot of times I'll give you the atomic symbol because osmium does sound like it could be a compound. So, fair question. So, number 7 and 8. These are no lie my favorite problems because I think they feel from the first idea they should be super complicated. But once you figure out the trick and the path, it's so much easier. So we know that a compound has a composition of 62.6% carbon, 4.20% hydrogen, 33.4% oxygen. What's the empirical formula? So, in this case, this problem has 3 steps. Step 1, we're going to assume you have 100 grams. Time out. I'm going to erase this so that we have a little bit more board space. So, because I feel like I'm going to start squishing the work, and you guys will be like, I couldn't see anything. Number 7, part 1. Assume 100 grams. So, that just means we're going to take our percentages and convert to grams. We're going to do that because it makes the math easy. You could assume that you had 5 grams, 10 grams, 5,000 grams. You could do that. But 100 gram basically means you erase the percent sign and write a G there and move on. And I like easy. So we're going to, for carbon, we have 62.6 grams of carbon. Hydrogen, we have 4.20 grams of hydrogen. And for oxygen, we have 33.4 grams of oxygen. Step 2 is to convert to moles. We're going to do that by using the mass from the periodic table. Divided by 12.01 grams in 1 mole carbon. That gives us 5.21 moles carbon. For oxygen, we're going to divide by 1.01 gram, and that gives in 1 mole, which is going to give us 4.16 moles of hydrogen. For oxygen, we're going to divide by 16, and that's going to give us 2.09 moles. Now, sometimes what you guys want to do is to just like, oh yeah, this is what we got. That doesn't always work. In this case, it is going to work, but on the exam, it will not work, okay? So now, step 3, we want to divide by the least moles. 2.09 is the least moles, so we have 2.09. And when you divide 5.21 divided by 2.09, we get 2.5 moles carbon. This gives you 1.99, which is approximately equal to 2. And this gives you 1. So now your empirical formula would be carbon 2.5, hydrogen 2, oxygen 1. But we can't have a fraction here. It has to be a whole number. In order to do that, we're going to multiply through by the least common denominator. So in order to make 2.5 a whole number, we're going to multiply by 2. We're going to take it at 5 halves. So when you multiply by 2, we will get 5, 4, and 2. So we have to multiply everything by 2 in order to get it into whole numbers. So we will get carbon 5, H4, and oxygen. Now, it does feel like we could have just stopped here. Sometimes you get lucky, but you cannot always stop there, so you should always check. Now, a popular question. is. Like, what fractions do we have to know? So you can multiply through. Normal fractions. Halves, quarters, thirds, maybe fifths. If you end up with like 0.99, that just rounds up to 1. Or 12.02 just rounds down to 12. You're not going to be asked to look at these values and know like 7/32. If it's that close, if it gives you a weird number, transition it to one of the ones that you know. So, what questions do we have about number 7? Including the use of the fraction here. In any case, if you have no questions and you thought it was super easy, you can go ahead and write that in the chat and we'll move on to number 8. Yes? Marlo, good catch. I just forgot that. Yes, the oxygen should be times 2. Good call, Sean. Christopher asks, is carbon 2.5 turned to 5? Yes. So carbon 2.5 is the same fraction as 5 halves. So in order to get it into a whole number, we multiplied through by 2. You might have to use the so Zach and Christopher and Dean. Okay. The reason we multiply by the fraction. So we have the 2.5 moles of carbon when we divide it by the least moles. 2.5 is not actually a value. In Gen Chem 1, we have to have whole numbers. Sometimes it can be something else. But we need to make 2.5 into a whole number. We need to do that by multiplying through all of the rest by a different whole number. So you can either turn it into a fraction and multiply through by the least common denominator, or you could say, okay, when I multiply 2.5 by 2, that's going to give me 5. It's going to make it into a whole number. So the fractions we will use in this class are the easily identifiable ones. When the fraction is 5 halves, if you multiply through by 2, you will get 5. So if you're like, look in your calculator and type in 2.5 or 5 divided by 2, multiplied by 2, and you'll get 5. We convert it into the fraction to make it easier to know what number we need to multiply through by. Good questions. If you guys have any other questions, why don't you go ahead and drop them in the chat. I am going to throw up number 9. Nope, 8, because I can't count. It's another one of these, so we can kind of, I like working multiple examples. And this one is going to use yttrium, bromine, and oxygen. 3 different elements that we used before. Total is not. So Jane brings up a quite excellent point. I must have written this problem. They should add up to 100. Or just use whatever numbers I gave you or Alex. Because in this next one, 41 plus 36.9. So in this one, they will add up to that. Perhaps sometimes when I write them, I must have written that one. So it should add up to 100. I know that there are some places where students are asked to make assumptions about the different components. That is not happening in this class. It is just what you see is what you get. So whatever the elements are the ones I'm going to ask you about. That's a great catch. I will make a note in my notes and try to fix that. If you have other questions, you can drop it right there. I'm going to erase this. I will leave our data plan up there so that we can do the next ones. If you guys have to go, because sometimes that happens, which is sad, keep in mind this video, because I'm going to solve number 8 and then go back and do the other 2 from number 3, will be on my channel. So you can find it in the semester playlist, or you can send me an email and I'll send you a link. So if you got to roll out, that's okay. I'm going to keep working these problems so you guys can have a record. So we have yttrium, bromine, and oxygen. So we have 41.0 grams of yttrium. We have 36.9 grams of bromine and 22.1 grams of oxygen. So now that's part 1. Step 2, we're going to convert to moles using the molar mass from the periodic table. Yttrium is 88.91 grams and 1 mole of yttrium, and that gives us 0.461. Bromine is 79.90 grams and 1 mole, and this gives us 0.461 moles as well. There are 16.00 grams and 1 mole of oxygen, and that gives us 1.38 moles of oxygen. So in this case, we can see that we have to divide by the least moles in order to determine the answer. So when we divide by 0.46, we get 1. 0.461, we also get 1. 1.38 divided by 0.461 gives us 2.99. 2.99 is close enough to 3 that you can round up to 3. So the final answer would be yttrium bromate, where we have 1 yttrium, 1 bromine, and 3 oxygens. So what questions do we have about number 8? And if you don't have any, you can just let me know in the chat that it was super easy and you loved it. Otherwise, in just a second, I'm going to go back and solve the other 2 parts of question 3 that we didn't get to. Thanks, Zach. So Hope asks, if it was like 2.7, could you round that? 2.7? No. Hopefully you don't end up with 2.7, but in 2.7 you could probably that should be a fraction. It should be 7/10. You hopefully won't encounter that very often, but that's what you would do in that case. So let's go back to number 3 so that we can answer those questions. I like these too. They're super fun. So in question 3, we're basically looking at atoms. Atoms to moles, moles to atoms, grams to moles, etc. So the last 2 are 2 just different versions of these calculations. Possum King, your question is slightly behind where I was, and so I'm not quite sure. I'm gonna need, so if you're asking, so 1.38 divided by 0.461 should give you 2.99, which rounds to 3. So I'm not sure where you're getting O2, unless you're talking about number 7, in which case, yes, it should be O2. All right, part C. How many copper atoms are in a 100% copper penny that weighs 3 grams? So we're really asking how many atoms are in 3 grams of copper. The fact that it's a penny is cool, but kind of irrelevant. So there are 3.00 grams of copper, and we want to know how many copper atoms there are. We need to do that by first converting to moles. So in 1 mole of copper, there are 63.55 grams of copper. So in 1 mole of copper, there are 6.022 times 10 to the 23rd. This is Avogadro's number. I almost said avocado, y'all. It's a lot. So this is his number. And there are that many copper atoms in 1 mole. So then you can just plug all of this in your calculator, and you should get, hopefully, 2.84 times 10 to the 22nd copper atoms. If you do this and you're consistently off, like anytime you have to use this times 10 to the 23rd value, it's not working out for you. My guess is you're adding that value into your calculator weird. If you're adding, so if you have a calculator that looks like this, you can use this EE button, which basically says times 10 to the, and then you just enter the power. So you can use that. If you have a graphing calculator, it has a like times 10 to the caret button. You can use that one. If you're using the multiplication button, make sure you're using a lot of parentheses because your calculator doesn't have a brain, so it's going to have some issues with that. If I said all of this and you're like, you know what, I only vaguely know how to use my calculator, come to my office hours next week. I will help you. You can hop into SI. She can help you on Zoom as well to use your calculator. Does anyone have any questions about part C? If you don't, I will go ahead and work part D. Questions, thoughts? Sorry we're running a little late. If you're hanging on, I really appreciate it. If you have questions, you can drop them in the chat, but I'll go ahead and start working on part D. So in this case, it's 2 different compounds, or questions. It asks, how many glucose molecules are in 5.23 grams of glucose? That is, in this case, this is glucose. You can assume if I give you some weird compound, I'm giving you that component. So in this case, we're going to convert to moles. So we're going to take our 5.26 grams of C6H12O6. We're going to convert that to 1 mole C6H12O6, which is 180.18 grams. So that would give us moles of glucose. From moles of glucose, we are going to convert to molecules of glucose. So in 1 mole of C6H12O6, there are 6.022 times 10 to the 23rd atoms. And I apparently forgot to stop my calculation there. 5.23. You are correct. So when you plug this into your calculator, you should get, using our 3 sig figs, we got 1.75 times 10 to the 22nd C6H12O6 molecules. Good. So that's the first part. So the first part asks how many glucose molecules are in there. The next one asks how many oxygen atoms are in this sample. To determine that, we're going to take our 1.75 times 10 to the 22nd C6H12O6 in 1 C6H12O6, there are 6 oxy atoms. Now, sometimes you'll note, so I write oxy because I found myself doing this. If it just says 6 O atoms, which you can't really see, that looks like 60. And you're not going to multiply by 60. You're just going to multiply by 6. So I'm going to mark that out. And you get 1.05 times 10 to the 22nd O atoms, or when you plug that into your calculator, and you should get the same answer whether you retype this into your calculator or just added the multiplication times 6 right here. So again, I'm so sorry that we ran over today, and I will just scoot myself right out of the way so you guys can see the answers. That's all of the questions we have today. If anyone has any other questions about any of the other numbers, you can go ahead and drop that in the chat. If you have no questions, y'all have a fantastic rest of the day. Enjoy. It's supposed to be nice and warm here in Jacksonville this weekend. Correction. I think it is, but I don't actually know that to be true. So if you have any questions, you can drop those in the chat. If they're super easy, that's great. You can write that in the chat too. If you are, I don't have any more for you today. So yes, you can do everything at once in your calculator. It should always work with the significant figures and the correct values. Any other questions today? If you are good, you can say none in the chat, or thanks, or later. So Anissa asked, on ALEKS, are we able to go back through the stuff we already mastered? You can. Up at the top bar, once you get into ALEKS, you can say, show me learned, instead of your path. I'm going to make a video like the Canvas video so that you guys can find it, so that you can do that. You definitely can go back in ALEKS. Sterling asks, where did the 180 come from? Yes, that's the molecular weight. And on a question, you would have to do that as part of this calculation. So you should show your work for that as well. I hope you guys have a great rest of the day. If anyone else has any questions, I'll hang out here for about another 60 seconds. Otherwise, y'all have a good one, and I will see you next week. Y'all are doing great. We have a mini exam on Monday. Stay tuned for the announcement on Friday that will go through all of the stuff we talked about at the beginning and everything else. Y'all have a great rest of the day. Bye, guys.